Hello and welcome everyone. Today I'll be trying to explain a sort of problem. So I'll be trying to talk about the solution of a problem taken from Codeforces recent educational round 139, problem number C, known as Hamiltonian wall. Okay, now, first of all, as you can see from the statement, what the statement actually talked about is, let's just in short try to brief summarize what exactly the statement actually wanted us to find out. Now, first of all, the statement says that we're given um, a grid, sort of grid with color white and black available, but the grid size would always be 2 times m, so the row would always be equal to 2, and the column number would be something that the user is going to take as the input. It's going to be 2 by m grid. It's going to look something like that, a 2 by m grid. Okay, and and each and every cell there could be two possible values that could occur, either black or white. Now, there's a constraint that this problem statement actually talked about, is that for every column, there has to be exactly at least one black, um, at least one black color. So um, possible solutions for every row could be black and black, black and white, white and black. So these are the three possible solutions that could occur, but no white and white, it's going to be the answer. So each and every row is going to consist at least one black color part. Now, the question now what we need to output is that whether it's possible to remove all the black colors using some brushes or something like that. So you can start from any index you want to start, and you would have to output you have to erase the black color here. That's like the bottom line here. As you can see, if I talk about this part, um, let's talk about only this small part here. If the as the input is given like that, and if you're given that whether you can actually erase all the blacks or not, and okay, let me dive into the movement part. The movement part is that, uh, let's say you select a particular point like that, you could only move the adjacent cells, not the diagonally. So you're only allowed to move on to the adjacent cells like that. And let's say a particular cell that you've chosen is this to erase that part. You could only move this or this. Okay, so adjacent cells, no diagonal part. Okay, adjacent cells and no diagonal adjacent cells and no diagonal part. Now let's now take one example from the test case here to get a good grip on how the things are actually working on. As you can see, let's take the first example, WBB and BBW. WBB, and then we've got BBW. As you can see, the answer is outputting that yes, it is possible to erase all the black. If you start from this index, you could go to this index because it's colored in black. And also, yeah, before diving onto that, also the problem statement also said that you can only erase consecutive black. If you occur any white position after removing cells, removing black portions. If you're forced to occur any white cells, then you cannot. Then you are not able to possibly complete your task. So you're gonna, if you really want to remove, you can. If you really want to remove, you have to remove all the blacks, and you have to do that all the blacks. You have to remove all the black portion consistently, and one at it only exactly once. You cannot just cross the line and move on to any sort of white position. But that's exactly what the statement talked about. Now, if I remove the black, no, if I start from this position, as you can see, I can move to the right because there's a black, and I erase both of these. And then as you can see, I've got the upper part here. I remove that. And as you can see, I'm also getting on the right part also a black color. So I'm also removing that, and thus completing all the blacks, removing successfully, erasing all the black colors successfully. So yep, that was like the part. And there are some other, if I give some examples with the answer no, it would be like, let's say BW and then WB, okay, and then let's say we have B and B. Now, as you can see, you could start with either this index or this index, but you can never complete the task. There's a specific reason for that. I'll dive into that later, but if you start from here, as you can see, yes, you have erased that part, but you cannot go back and move here, okay? So if you have already erased a black color, you cannot just go back to that again. So you cannot just move from this black to this black. So as you have already chosen this path, as you know, you're forced to be in a cell which is white. So you cannot just, you're not able to complete your task. If you start from this index, you, okay, I guess I was, and now if you start from this index, you go to the up, you go to the right. As you can see, everything is running on smoothly, but now what you're going to do next? You have no other options but to go to the down. As you can see, down and right both are forcibly white. So you cannot just cover and erase this B. So you're not able to complete your task. Now, let's get into the main intuition behind solving this problem. And let's see. The main intuition is that always look for the resistant part. As I've already told you, the resistant part here is the white color. So white is the resistant part, right? So you would only look for the cells which are colored with white. So there could be two possible ways, either white and black, or maybe black and white. As I've already told you, I'm only going to look for the resistant part, which is the white portion. So I'm only going to look for the column which consisting of only the white, white or the barrier part. Now, after that, what you're going to do is that you will look for patterns, consecutive patterns like that, white, black, and black, white, or maybe black, white, like that, or maybe white, black, and white, black, like that. So these are the three cases that you need to take care about. Excuse me. And as you can see, these three cases that you need to think about. Let's talk about the first case, white, black, black, white. Now think about these two cases as a separate cell. So if this was the cell initially given, would you be able to complete the task in any way possible? No, it's not possible. So as you can see, in between them, there are no cells, or I could also say there are even number of cells. As you can see, as I can say, 0 is also an even number. I could also say something like that. If there were odd number of cells of valid, even number of cells, let's say, if I need to verify that, like that, you would never go you would never complete the task. But and this test case without these part also prove the assumption here. As you can see, you cannot just dive into from WB to BW and complete the task if in between there are even number of those verified black cells. If there were odd number of black cells, let's just remove that to prove the part. If there were odd number of black cells, just like that BB, then there's a possibility that you can go. How? You move there, you move here, and then you move here. Okay, go right up and down. Similar case goes to these cases, these two cases. As you can see, think about it as a particular cell that you're given. Now, for this particular cell, you can easily see that you can easily move from the right and you can complete the task. Or you can also say that, okay, in between there are even number of cells and I am able to complete my task. If the pattern is like BW and BW, or maybe WBWB. As you can see, both of these cases, if there are even number of in-between black cells, even number of in-between black cells, as you know, 0 is also consisting the even number. So you could say both. And yeah, they are all performing perfectly well. Now, what's going to happen if there were odd number of cells in between BW, BW, this case, or maybe this case? Let's take a small look into the example part here, and we're going to see BW, let's say BW, and okay, let's see. Okay, let's take a look at for this part. As you can see, BW, BB, and BB. Now, can you complete your task? Is it possible? No, it's not possible because there are odd number of BB for the pattern BW, BW. Okay, for the pattern BW, BW. But if there were odd, even number of these B cells, you would be completing the task like this. So as you can see, the main trick is that you would try to find out 3 patterns, WB, WB, BW for that particular case, WB, or should I say BW, WB for that particular case. If the in-between B cells are all even number, you would not be able to complete your task. If the in-between B cells are odd number, you would be able to complete the task. And for the other case that we talked about, BWBW or WBWB, the same condition, just gonna be the vice versa of what we did here. So as you can now, let's take a look at the code part here. As you can see, we're considering the two different conditions here. The first part, I think, yeah, just these are all just simple implementations. As you can see, taking the flag of f of b, w, and wb just to keep track of what happened. Did we get any pattern like that, BW or WB related? And according to that, we're making our assumptions. What are we getting now? Whether are we getting WB or are we getting BW? And according to that, we're making our assumptions. We're detecting either these two cases and verifying whether the number in between them is even or odd. Whether the number in between them is even or odd, meaning that their indexes difference. The difference between, let's say you found one pattern here and one pattern here of white, black, and black, white, but in between there are all blacks territory. So you would count these numbers because that's needed in order to verify whether you're actually going to be able to complete your task or not. And that's exactly what we did here. So that was pretty much the whole explanation. And I hope you enjoyed the video. Till next time.